So the next thing we want to talk about is what are vectors and the graphical representation of vectors. When you look at a vector, you usually see nothing more than unknown length, whatever. But in truth, when looking at a vector, there's two things that you've got to keep in mind. The first is that should be representing the direction. If an object is going off at 30 degrees with respect to the horizontal or something along those lines, you should have this pretty well, not necessarily measured out. I mean, it depends on the situation. If you're doing a quick sketch, obviously this is going to work. But if you're actually performing vector addition using the head-to-tail method, you're going to want to make sure that you measure this out carefully in the portrait. Okay? So this angle needs to be represented when drawing vectors. That's the direction of that vector. Okay? The other thing you have to keep track of is the length. So from the tip of the arrow to the tail, that length represents the magnitude of the vector. As an example, let's say that we have a force, which force is a vector, and it's something like 20 newtons at 5 degrees. An equal sign there. Okay? At 5 degrees. So what I need to draw, if I'm going to do this, I'm going to do a sketch of what that should look like. Well, 5 degrees is pretty small. So 5 degrees at 20 newtons. Now this should represent the relative size of that 20 newtons. If I come in and I draw another vector at 10 newtons at 10 degrees, I should have twice the angle, but half the length. Okay? So those vectors should represent those numbers. Now if we're doing vector addition, like I said, you better make sure that you got yourself a protractor and you're measuring that 5-degree angle. Okay? So you better make sure of that. In addition, this length should somehow represent 20 newtons. Whether it is 1 inch equals 1 newton, or 1 centimeter equals 1 newton, or you have a big enough piece of paper, 1 meter equals 1 newton. That vector should represent that length. So if it's 20 newtons, whatever your scale has to be, whatever it is, that thing should represent the length, especially when you're doing it for head-to-tail method. If you're just sketching, just keep in mind that the relative size of it should be, comparative. How do I put this? The size of this should represent its overall size compared to other vectors. So if it's twice as big in this case, it should be twice as long. If it's at 5 degrees and the next one's at 10 degrees, this one should have twice the angle. Okay? That's what we're talking about when we talk about graphical representation of vectors. These vectors, the length represents the magnitude. So a bigger force should have a bigger area. Cool? All right.